Alrighty, this is Activity 1, Lesson 1-2, more geometric figures. I want to go ahead and apologize for my voice. It's just, it's going away, so I apologize and just bear with me. Throughout this lesson, our learning targets are to describe angles and angle pairs. We're going to learn a lot of different pairs and how to describe angles and their characteristics, and also we're going to identify and name some parts of circles as well. This first paragraph says, as you share your ideas, be sure to use mathematical terms and academic vocabulary precisely. So as you watch this and as you catch yourself thinking about the angles and the relationships that we're talking about, you need to make sure that you're using the mathematical terms, using those correct descriptions and saying that's a ray, that's a line, that's a segment, that's a vertex, so on and so forth. And also your academic vocabulary precisely as well. For example, what we're going to do in item 2 is compare and contrast. And like I've said in the classroom, just speak geometry, speak mathematical. Make sure you make notes to help you remember the meaning of new words. We already got a whole bunch listed out over here. We'll get there in a second, but please make sure you're taking those notes. Even if I don't write the notes over here, you can pause this video and make your own notes off to the side, or just re-listen to it because I'm going to be talking pretty fast. So help you remember the meaning of new words and how they were used to describe mathematical ideas. All right, let's get started. So number 1 says, draw 4 angles with different characteristics. Describe each angle. Name the angles using numbers and letters. So when it asks for different characteristics, we're not talking about different names. Okay, that's not what it's going for here. It clearly said name the angles using numbers and letters. So they want you to name them differently. But we're looking for distinct characteristics that are different. And you should be aware of 4 completely different angles just in your previous math classes. The first one we're going to talk about is an acute angle. An acute angle. So I'm going to go ahead and make a quick sketch of one. An angle that's obviously acute. So here I have an acute angle, angle ABC. I'm going to refer to this angle as, when I name this, I could name it angle ABC. I could call it angle CBA or just angle B, but I'm going to refer to it as angle ABC. If it is acute, then we know some things about its measurement, and so when you're talking about the actual geometric object, you would use this notation with just the angle symbol, because this is talking about the geometric figure, that object. But when you want to start talking about its measurement, one of its properties or one of its characteristics, you must put a cursive M in front of the angle symbol. So now this reads the measurement of angle ABC. And when an angle is acute, we know a couple of things. It's got to be less than 90 degrees, but also when it's acute, or if it's just an angle, it's got to be greater than 0. This is the first angle that we're talking about, is an acute. I just drew an example of it. We know that the measurement of that angle must be less than 90 degrees, and the measurement of that angle must be greater than 0 degrees. Don't forget your units. Okay, 90 what? 90 unicorns? Like, what are we talking about here? Please don't forget to put your units. The next one we're going to talk about is obtuse angles. Obtuse. Draw a quick sketch of an obtuse. I'm going to make it obviously obtuse. I'm going to name this angle. I'm going to put a little number in the interior. So this is angle 3. And so if I were talking about the object, or if I wanted to describe this and compare it to other angles, I would say angle 3. Or angle 3 is coplanar with line L, or whatever. When we're talking about the object, we use this notation. We say angle 3. But when we want to start talking about its measurement, that's when you put that M in front of the angle symbol. And now you're talking about a numerical value, some numerical value, and that's why we're allowed to use an equal signs and these inequalities, less than, greater than, and we can actually add these measurements up, and so we can start using arithmetic. But when you're talking about objects like angle 3, you don't use words like angle 3 equal to. Like, you just don't do that. You need to talk about some sort of measurement, and so that's what this allows us to do. So when an angle's obtuse, we know that it's got to be greater than 90 degrees. But also, when it's obtuse, the measurement of that angle's got to be less than 180 degrees. So again, don't forget to put your units and making sure that you are using proper notation. When we're talking about the measurement of these angles, you put that M. The next one that we all should be familiar with is a right angle. A right angle. So I'm going to go ahead and draw and I'm going to label this guy P, T, R. Just random points, PTR. As I have it drawn now, it may look like it's a right angle, but if this is a diagram that you get on some homework assignment or quiz or test, if it just looks like this, you cannot assume anything. You cannot just assume that this is a right angle because it looks like it. As I've drawn this right now, we're not sure what angle this is. It may be right, it may be acute, it may be obtuse. It is not until you put that box or that notation in the interior of the angle to make it clearly a right angle. So please do not forget that. If you don't see that, or if you can't deduct somehow that it's a 90-degree angle, please don't ever assume. I'm going to call this angle T, because that's by its vertex. I'm just going to refer to it as angle T. When an angle is right, we know that the measurement of that angle, whatever it may be, in this case angle T, is equal to exactly 90 degrees. The last one I want to talk about is a straight angle. A straight angle. And a straight angle legitimately is 3 collinear points. So I'm going to call this R, T, Q. So angle R, T, Q, these 3 collinear points, it is an angle. So I'm going to call it angle RTQ. Our vertex is point T, and the 2 rays that make this up are opposite rays. So if I want to look at ray RT and ray TQ, those are opposite rays. And when this situation happens, it forms a straight angle. And the measurement of a straight angle, in this case RTQ, is equal to exactly 180 degrees. Now, when it said draw 4 angles with different characteristics, again, it wasn't talking about the names, and these all consist of the same parts. Like, each one of these angles has a vertex. Each one of these angles is comprised of 2 sides, which we know their geometric figure are rays. So they all consist of vertices and rays and so on and so forth. But when you talk about their characteristics, like, how are their measurements different? And could they be supplementary? Could they be a linear pair ever? Or do they have a complement? Do they have a supplement? And that's things talking about there. Those are the characteristics we wanted to get in, and we're about to get into more of those terms down here in part 2. So part 2 says, compare and contrast each pair of angles. And so as we did this in class, if you look at each item, like 2A, this diagram here, there's 2 angles. In C, there's 2 angles. In D, there's 2 angles. In B, there's actually 3 angles in this diagram, but they wanted you to look at, if I were to put interior numbers in there. They wanted you to check out these two guys and compare them. So not only are we going to take each individual pair, compare and contrast the two that make them up, but I want to take this pair here, and compare it to the pair that's in B, and take this pair that's in A and compare it to the pair in C, and so on and so forth. So this next part, item 2, there's going to be a bunch of information right here. So if you need to pause, or if you need to re-listen to any part of this video, please do so, because this is some really important stuff. The first item, item A, you have these two angles named angle 1 and angle 2. Now, there's some clear and obvious similarities and differences, because don't forget, over here it says when you compare and contrast two figures, you describe how they are alike or different. So you know, don't just be negative Nancy's. Don't just say, oh, they're different here, different here, different there. You know, share some ways that they're alike or similar as well. So for these two angles, okay, obviously one's acute, one's obtuse. Okay, good. So their measurements are absolutely different. One is greater than the other. Some things that they have in common: they share a vertex. So we see that. They have this common vertex. Another thing that they share along with that vertex is both angles are made up of or contain or consist of this common ray. So they also share a ray. Another thing is that they have no common interior points. So what I mean by that is, if I were to place a point here and say point R is in the interior of angle 2, and it's not in the interior of angle 1. These two angles share no interior points. It's impossible to draw a point right now that is in both of the angle's interiors. It's impossible. Well, when these three things happen, it's a very unique situation, and we have come to understand and call these two types of angles adjacent angles. And hopefully you have heard that term before, that, you know, this building is adjacent to this park or something along those lines. But adjacent is just a big fancy word of saying it's right next to. And in mathematics, if you have adjacent angles, three things have got to be true. There's always going to be two. So two angles. Make note of that. First off, common vertex, or they'll share a vertex. Common ray. They will share a ray. And when I say ray, I hope we all know that means that's a side of that angle. And then no common interior points. Now another way of looking at that, saying that they have no common interior points, you could say that they don't overlap. Do not overlap. The angles don't go over each other. Because if you look at item B, you have the whole angle, you have the right angle ADC, this whole guy. Well, that is on top of angle 1 and angle 2. They overlap each other, so that can't happen. You can't have overlapping angles. And again, the mathy way of saying that is no common interior points.